The time has come to start working with an ERC721 NFT staking smart contract that will issue its holders staking rewards in the form of ERC20 tokens. Okay, so let's see how that goes. I hope you liked this video. I would like to also announce that I have an Ethereum wallet in which you can send your donations to help support my channel so I can keep doing this content for you guys. If you find my content very useful, any donations help. Thank you so much. There you go. net2dev.eth. That's my wallet address. In the last video, we discussed high level how everything communicates from the staking contract to the ERC721 NFT collection. How do we validate that the NFT that is going to be staked is part of the collection that we want to offer rewards? Also talked about how the NFT staking smart contract talks to the ERC20 token smart contract and calls the mint function and issues the token down to the staker's wallet, or in this case, the NFT owner's wallet. Okay, now we have to take a look at the code. So we are going to explore in this video how the smart contract looks like, how the NFT staking smart contract looks like from a function standpoint, and how does it interact with the ERC20 token smart contract and the NFT ERC721 collection smart contract. Okay, so now let's take a look at that. Let's get familiar with all the function, in particular or especially the claim function, in which the end user will hit the claim button and the NFT staking smart contract is going to talk, or is going to send the request to the ERC20 staking token rewards smart contract and mint the reward token or the staking tokens and pay the end user or the staker its staking rewards. Alrighty, let's get started and let's jump right in. Okay, let's continue the party. So what we need to do, we have built the Solidity file. I will be explaining how does the NFT staking smart contract works, or how it's coded to perform that staking function, as well as the token rewards, as well as issuing the token rewards to our end users. Okay, so the first thing, obviously, we start with Pragma Solidity and the compiler version above A4. Okay, so the next thing I'm gonna do, I'm just going to be copying and pasting, because it takes a lot of time to type. What do we have here? We got two smart contracts. The first smart contract is our NFT collection smart contract. And you remember on the last videos, on a couple of videos ago, I actually coded an ERC721 NFT collection. So basically this is the contract. This is the contract file, okay? And I'm gonna go through it so you can know, so you can get familiar if you haven't. So you can refresh your mind about the ERC721 smart contract, okay? We have decided to create a staking token named N2D rewards. This will be the ERC20 smart contract token that will issue the staking rewards to the NFT stakers, okay? So with that said, the next thing I'm going to do, I am going to create that contract, and we are going to add a couple of features. Okay, so we start the configuration by enabling the contract, which is ownable. I am not calling that as an external import, because the collection, the ERC721 NFT collection smart contract and the rewards are ownable, so I'm just literally calling from the other two smart contracts. And you're going to see that once we go to remix and compile the contract, you're going to see that it's going to be able to find this particular interface and call it in the contract without actually calling the open sepling ERC 721 ownable interface. Okay, and also we are going to enable ERC721 receiver, which is the interface to send and receive NFTs into this particular smart contract. That allows me to send or receive NFTs into the staking contract. This is how we store those NFTs in. Okay. I created a variable, a public variable called total stake. This is the total amount of NFTs staked by a particular user, and this is basically how we store that value. We store that value using total stake, and we're just going to call that in the contract itself. You're going to see that for a while. You're going to see that in a bit. Okay. We open a struct. A construct, so basically stake. What am I looking? I'm looking for a token ID, right? And this is integer 24. This is the amount of digits the particular attribute will be allowed to be stored, up to 24 in the UINT digit range, okay? The timestamp, that is very important because we need to know when did the user execute the staking function. So we need to capture the timestamp, and we need to start calculating the block rewards the moment that timestamp is alive on the smart contract for that particular stake action. Okay, make sure that you remember that. Also, obviously, the owner. You know, we need to know who's the owner of that NFT so we can return the NFT if he decides to unstake the NFT or she decides to unstake the NFT. Okay. Event. We are going to store 3 events: staked, unstaked, and claim. What are those? Basically, we want to store, or we want to call this event as long as we can get those particular values out of the particular action. Okay, let me explain. I need to obtain the owner address, or in this case, the NFT owner's wallet address. I need to also grab the token ID from the NFT, and I also need to know the value, if there is a particular value on the NFT. Okay, I need to know that, and this is how I will be calling the event, and basically that information will be stored in the event. Same goes with the unstake. It's basically the same thing. And finally, the claim, this is different. So the claim, it's basically, you know, call that event by giving me the owner wallet, or in this case, the NFT staker's wallet address, and what it's the amount of the tokens that were issued to that wallet as a reward. Okay, you're following me, right? If we need to call 2 functions, no, we need to store 2 variables. We need to store the output or the information from the collection smart contract file inside NFT. So what I'm doing, basically, let me explain real quick. Basically what I'm doing here, I am literally telling, hey, from the collection smart contract, this is the ERC721 collection smart contract. This is not the staking smart contract. This is our actual NFT collection that we are allowing to stake in this contract. Let's store the information from that contract as the NFT. So anytime that I need to invoke something that it's going to talk to that collection smart contract, it uses this particular value to reference this particular smart contract. This is how we actually map smart contracts together. All right. Also, the N2D rewards smart contract, or this is the token smart contract, will basically be stored with the value of token. So all the information inside the smart contract will be stored here, and then we can call this to interact between this smart contract and the rewards, the token rewards smart contract. So this is how I can invoke and send requests to this particular smart contract to mint those ERC20 tokens, okay? And those are your staking rewards token that we want to pay the users for staking their NFTs, okay? Next, let's grab this, basically, and we are going to map those values. What are we doing? We are mapping into the stake as the vault. So we are mapping this particular struct as public vault. So that means that will be my vault. No, I am going to hold the NFTs inside that vault. What is that vault composed of? It's composed of the stake construct, which is the token ID, the timestamp, what time did user stake their tokens, and obviously the owner or the user that staked the tokens. So that basically, it's a public reference to the stake construct, so we can call that, or the end user can call it to find information about the smart contract. So we need to know that. We have to pay good attention to that, because if we don't, we cannot provide the end users the information about their tokens, if they're staked, when they were staked, and we cannot call other functions as, hey, how many NFTs or how many staking rewards I've earned by staking this, since last week, stuff like that. So this is why you want to do this, okay? We are creating a constructor that will open two functions, the NFT and the token function. The NFT ERC721 smart contract, and the token, it's basically the rewards token, ERC20 smart contract. So we got that? Okay, now here comes the fun part. We are going to stake, listen carefully, we are going to stake in this function. We are staking the token ID that the end user has on his wallet or her wallet. Let's say that user bought token number 1, token number 2, token number 3, or NFT 1, NFT 2, NFT 3. What I need from the end user is to specify which tokens from his wallet or which NFTs from his wallet does he want to stake. He might have 20 NFTs, but he only wants to stake token 3, 4, and 5. Only those 3. So this is how we can get the information from the end user of which NFTs does he want to stake in the smart contract, right? So in this case, let's say the user wants 3, 4, and 5. With that, he just needs to point 3, 4, and 5 inside the array. So here, he can actually store that information and send that request to the staking function, and then the staking function can pull the NFTs from the user's wallet the moment the user stakes the NFTs, okay? We are going to start by calling the token ID. So we need to get that information from the end user. The end user needs to provide which tokens does he or she wants to stake. Total stake, it's the amount of token ID. So this is basically me saying if he staked or she staked 3, 4, and 5, what's the total of 3, 4, and 5? For 3. He staked 3 NFTs. So that's basically the sum or the whole amount of NFT staked. This is what it's doing. It's storing that as total staked. We are going to store each individual token ID in this for loop to start issuing the rewards per token or per NFT. If we don't create this for loop, I cannot go through every single NFT and issue individual rewards. So that's why this is configured that way, because I need to, hey, I want you to perform the staking calculation per NFT. And this is why we're doing this for loop. It's because we need to have a single staking action per NFT. Even though that I send 3 NFTs to be staked, I need to calculate the function per NFT, okay? And, I need the owner wallet. Hey, make sure that we attach that token to the right owner. So then once the owner retrieves or requests the unstake function, it knows, the smart contract knows that it came from XYZ wallet. So we need to make sure that we can return the NFT to the right owner, right? And this is how we do it. We map it to the owner wallet, token ID mapped to the owner wallet. The moment he stakes or she stakes, that information is stored, and then we can execute unstake if he wants to get the NFTs back, okay? And this is basically, hey, this is calling the action. After getting all that information, it basically does the transfer and grabs the NFT and throws it or stores it into the staking vault that we have just created. And here's the staking vault, calls the stake constructor, which includes the message.sender, which in this case is my NFT wallet, and the token ID of the NFTs that he or she wanted to stake, and what specific time did they start to stake those assets onto the vault, okay? Next, I do have the option to unstake, right? So what am I going to do now? I am going to unstake. I am going to give the opportunity to the end user to unstake if they want to, because you definitely want to have that, because if the end user doesn't want to stake the NFTs anymore, you have to make sure that you can return the NFTs back to their owner, right? So by doing the function to unstake, I can actually call another function to do the opposite, to just return the tokens back to the rightful owner, and I can actually unstake multiple tokens at a time. So let's say one owner decides to unstake 3 tokens at a time, we should be able to allow them to, not a single token stake. Because let's say the user has 5 tokens and he needs to execute this function 5 times, it's going to cost some gas fee. So that's why we want to avoid that by creating a single function that just pulls all the NFTs all at once if the end user wants to. I'm not saying that that's mandatory, but if the end user wants to unstake everything on a single transaction, let's save that user some gas fees. That's why we're doing this. Okay, awesome. We are going to claim, and this is the magic right here. The end user decides to retrieve the rewards that he or she has accumulated so far by staking the NFT. What we need to do is we need to grab the information from the wallet that the NFTs came from. We are also calling the token IDs, and I set up a Boolean option to unstake, which means that inside the same claim function, I can tell the end user, hey, do you want to claim and unstake? Or do you just want to claim but not unstake? With that, I just need to provide yes or no. If yes, it means that not only you want to claim those rewards, but you also want to unstake. So we're giving the opportunity to the end user decide to keep the NFT staked. He just wants to retrieve the tokens or the rewards, but leave the NFT staked. So this is why we have a Boolean. This is an internal function because this will be called internally by the smart contract. Then we'll have an external call that will be done by the end user. This is the magic right here of the staking rewards. So this value right here, it's the amount of tokens that we want to issue to the staker every time we have a block process, or there's a time. So every time that happens, we are going to issue this amount, but this is not 10,000. This is not like we're issuing 10,000 tokens. And this is the value that I placed myself as an example, but you have to come up with your own formula of how many tokens rewards you want to grab, or you want to issue to that end user. So you have to do that math yourself, but basically what it does right now, I am issuing, this is a measurement in GUI, Ethereum measurement. So you have to come up with your own calculation in order for you to know how much do you want to issue per token or NFT staker every time there's a block process. And what we are going to do, we are going to multiply that by the amount of block timestamp. But first we have to resolve this calculation right here, which basically is going to grab the stake time when it was staked, and it's going to subtract that by the latest block timestamp. So the latest block that was processed, I am going to subtract that, and that will then be calculated because that will be the amount of blocks processed times 1,000 or times 10,000 divided by 1 day. That gives you the amount that the end user will earn and rewards. Next, what I'm going to do, I am going to grab from the vault the token ID, the NFT ID, and from the NFT itself, we are going to find the account owner or the owner wallet, the token ID, and the timestamp on when it was actually staked. And this is very important. If there's more than 0 earned, and you can be more specific, right? I am just saying more than 0, meaning that if the end user earned 0.0001 token, I am allowing them to claim, right? But you can be more restrictive, so then you at least keep the NFT staked for a longer time, right? So let's say if the amount is higher than 0, then proceed. Earn equals earn divided by 10,000, which is the amount that we specify in the smart contract. Then issue the mint. Mint, it's the message that sender, in this case the NFT holder, wallet, and the amount. So what is going to happen now, it's going to send that request to the ERC20 smart contract, and it's going to perform the mint. The smart contract, the ERC20 smart contract, is going to perform the mint, and it's going to send those tokens to the NFT holder's wallet. If the end user decides to unstake, simple. I am asking for your wallet address. Let me find you on the vault. Get me the token IDs. Oh, yeah, you're staked. Okay, sure. There you go. There's your NFTs back. Okay. And we are then triggering the event of claim that we configure on the beginning of the staking contract. So we have, there we go, event claim. Here we go, right here. Okay, so it's basically called that, and we have that event triggered on the smart contract. We need to provide the end users some visibility, right? We want the users to check how many tokens they have earned so far and so forth. And this is where we go with that function of earning information, which is basically doing a really similar approach as the claim, which is calculating the rewards, but it's not issuing any mint. It's just finding out what's the current value. So every time that the user checks the token rewards, how much he or she has accumulated so far, it triggers that function and it gives the value. Value is going to be very raw, but we have to format so it shows a decimal value, so the end user is, aware that he's not actually getting a quadrillion tokens. He's actually getting, 1 or 2. Okay, because it's going to be a large number. It's going to be a big number. We can provide the end user, hey, what's the balance of this particular account? In this case, how many tokens do you have, or how many NFTs do you have staked on the vault from your wallet address? Okay. Also, we got the tokens of the owner, so we can actually call, hey, which tokens are staked in a particular vault, or in this case, in the smart contract vault. Right? Another thing that I want to do, but I'm not going to do in this particular video, what I'm going to do in the upcoming videos after we mint this whole staking smart contract with the ERC20 smart contract and we interact and you see the earnings and all that, I am going to create another smart contract that we can have multiple vaults. So instead of you having a single smart contract per NFT collection, then you can have multiple NFT collections all using a single smart contract, which is even better because it's less complex to maintain. If you deployed a Web3 application that talks or interact to a smart contract to provide the end users the actions of staking and all that, you don't need to build a bunch of functions or a bunch of JavaScript code to talk to every single contract. You only have one contract. So that's a huge benefit. I am going to provide another video which I will just add the vault, the multi-vault capability, okay? Awesome. And what else? What else do we have is basically the tokens. It's the amount of tokens that the end user has earned by staking their NFTs. That's the value. It's basically stored here, which we can then send that output to the end user so he is aware of how much staking rewards he or she has accumulated so far. Finally, we got on ERC721 received. Basically what it does, it's a way to control how do you receive those NFTs to be staked. So basically I am receiving the ERC721, but I want to make sure that I use the functions that I specified. In this case, I need to make sure that the address that you're sending me the NFTs from, it's approved to be the staker address. In this case, you're not just calling this outside of your normal function. It's a way to protect the smart contract from exploit, etc. You're not actually calling this natively on the blockchain. It has to follow the claim function. So then you control the NFTs that are staked on the vault, etc. I can go very deep into the configuration aspect, but I don't want to make the video too long. It's basically a way to protect or regulate how the NFTs will be staked on the vault, and they all the stakers, they have to follow the same procedure. We're not just going to allow to raw stake any tokens and bypassing the claim function, etc., or the staking function, etc. Okay, so what I'm going to do, I'm going to wrap it up. I know that's a lot to digest on a single video regarding the NFT staking smart contract, but don't worry. As we go into the series or the video trading series, you are going to understand pretty much everything, how everything relates, how everything communicates, and how everything interacts between each other. We saw how the NFT staking smart contract works, or how it's configured, how it's structured. Now in the upcoming video, what I'm going to do, I am going to create the ERC20 staking rewards token smart contract. that needs to be configured so only the staking smart contract can perform calls to that ERC20 and issue the tokens, okay? Alrighty, so that's it for this video. I hope you like my content. If you find my content to be very useful, I will gladly appreciate that you hit the subscribe button, like, give it a thumbs up, and let me know if you have any comments, any doubts. Hit me up in the comments and I will do my best to answer that as soon as possible. Thank you so much for your support and we'll see you on the next video. Bye.